This is video 33 that I'm doing for composite design and analysis in CATIA, particularly using its native FEA solver, which is not well documented. Now, in videos, we looked at this problem in video 31 and 32. In 31, the skin, this is the skin, these two are the top and the bottom skin, and this is the honeycomb core. In video 31, these are all modeled as layers of a composite, okay? So layer 1 here with its own property, layer 2 with composite properties, honeycomb composite properties, and layer 3, which is exactly the top. So basically, the problem was done with shell elements. Then in video 32, I repeated this problem except that the top and the bottom skins were modeled with shell elements, but the honeycomb core was modeled with solid elements. However, everything was done within a single part. So what I would like to do now is repeat that problem except that the top skin, bottom skin, and the core are all individual parts. There are some subtleties involved when you do it like that because these are different parts when they're meshed. The nodes do not match, and because of that, in order to see how one affects the other part, then you have to create what is called analysis connections. Okay, so now the first thing I'm going to do is input the material properties, create a library which has the two material properties for the face and the core. And although this is repeated in the last two videos, because you may not have seen those, and it's a good idea if I did this thing from scratch. Okay, so let's go ahead to to CATIA. I already have a product file created here, but what I want to do is first the materials. So I go to Start, Infrastructure, Material Library, and I'm going to create two materials. One of them is for the face. So we go the name of this thing I'm going to call face, and it doesn't matter whether it's the top face or the bottom face. Or let me call it skin. How about that? Skin. Skin. Okay. And apply. The name changes here, obviously. Right. And on the composite, for the thickness, I used the same one that I used before, 0.7112. That appeared in the table that I showed you, 0.7112. Yep, right there. Okay, and these are the numbers that I have to put in. There is these numbers, except for the last one, there is no room for the last one. There is no such a thing as normal modulus when I do it as 2D orthotropics. So this is, by the way, I'm going to make it unidirectional, although it will not affect the analysis stage. So apply. Okay, so we go to analysis. We're going to use 2D orthotropic, and these are the numbers that I was talking about. So this one is 68947 MPa. So this is the Young's modulus, longitudinal modulus for the lamina, and then this one is 27579. The Poisson ratio, we are told that is 0.3. The shear modulus in the 1-2 plane, or the XY plane, the plane of the lamina, is 1298 megapascal, 12928, sorry, 12928, and it's the same in the other two planes. So same thing here, 12928 and 12928. 928. Okay, and we don't need the density because we're solving a static problem. We don't need the strength properties because that's not what we're doing. So apply and okay. Then I create another material, and we're going to call this thing the core. So the name, we're going to call it the core. Okay, so see, we don't have to do anything with this tab, composite tab, because we are not modeling this thing as a shell element, as with shell element. So although I clicked on it, we're not going to be using it. I'm not going to change anything here. These are totally irrelevant. So we go to analysis and we use honeycomb. And notice that for honeycomb, we need only 3 numbers to input. This one, if you look at the table that I showed you a few minutes ago, it's on, just back it up here. This one, this table, uh, that is this number 689476, 689476. Okay, MPa. For shear modulus in the exit plane is 209.6. And for YZ plane is 72.69, I believe. 72 point, sorry, not 72, 82.74, 82.74. So this is going to be 82.74. Okay, apply. Okay, it's always a good idea to check these, make sure nothing was changed inadvertently by the software. This is not changed, and the composite thickness is 0.7112. This is the core for it's a honeycomb. These are the numbers that I put in, and under composite tab, I didn't make any change. I didn't do anything. We don't use this. We don't use the composite tab here for our purpose. All right, save it. This is going to go into that folder, assembly, sandwich, etc. Should be solid, not soiled. Let me give this thing a name. What is it? Assembly. How about that? Assembly sandwich structure. Sandwich. Okay. All right. Let me close this. Now, you need 3 parts, but you can create these 3 parts with the dimensions that were given here in the table separately. Or my habit when I teach the CATIA assembly design to finite elements with it, I do everything within this environment. So first thing I'm going to do is I'm going to say insert a new part. I'm going to make the core first, new part in there. And I'm going to call this thing the core. Right click, properties, core, core, core. Okay, there we are. And to make it, I just double click on the core. Second line in the core here is a part design. It'll take me to part design. You can see that. It'll take me to part design. I am in part design. Okay, I'll make it. So on a convenient plane, on that horizontal plane, I will sketch a rectangle, or a square actually. Dimensions 254 by 254. That's the size of the part that we're looking at, 254. And 254 here. 254. And exit. And I'm going to pat this thing in both directions by the thickness of that core. The thickness of that core is 19.05, but because I'm doing a mirror extend, I have to input half of that. Okay, so in here I put down 9.525. If you double it, you get 1905 that you want. Preview right there. So this is going to be my core. Okay. Now, while I'm here, I'm going to apply my material to this. So your material is well, actually, we can do that later on. Don't worry about this. Okay, don't worry about this. So the only thing is that I want to extract that face. I want to extract that face for a reason that may not be obvious to you, because later on, if you have watched the previous video, video 32, you know what I'm talking about. If you extract this face, you can put a nice mesh on it, a nice quad mesh on it, shell, and then sweep it through the thickness of the part. So get a nice uh, brick type elements all the way through. And then you deactivate the mesh that I use in order to sweep this thing. So let me go ahead and extract that face. So we go here to uh, generative generative shape design. So we're going to extract this face. Okay. All right. And let me give this thing a name and call it properties top of the block. How about that? Top of uh, the core. Top of the core. Okay. And and say apply. And let me also change the name of that for graphics. Let me change the color of that because I'm going to have another surface which is exactly on top of this for the part one, the top skin, and I don't want them to get mixed up. So let me change the color of this thing to orangish. Okay, good. All right. Now, uh, I will do the meshing and everything later on, okay? Although it can be done right now, but I will do everything later on. Okay, so we are done with this. Let me see, do we need anything else? The answer is no. So let's save everything, which means my product and this part in the folder that I have. Okay, so now I'm going to go insert a new part in there, and I always say no. So change the name of this thing to be the top face. So properties under mechanical or under product top face. You know what? Actually, I'll call it top. Uh, yeah, top face, top face, and this one top face. This is the one is the instance name. The other one is the part name. Uh, Top face, and let's go make it. You double click on this, and uh, you see over here, one thing you can do is that you can create these three parts separately and then assemble it, okay? But what I decided to do here is that I'm going to create that top face exactly where it's supposed to be instead of me moving it, moving it and then uh, yeah, and then moving it and then create assembly constraints. So I'm going to create a plane which is uh, this much half of this height above the middle surface. So let's see now, where's the plane here? Right there, plane, offset from the XY plane by the amount which is exactly halfway, half of the height of the core. So it's going to be 9.525. Okay, 9.525. So there it is. This is the plate. And on that plane, I will sketch a rectangle exactly that size, square exactly that size. Please note that these are not the only way of doing it. You may have a better idea of how to do this problem as far as generating the model, but this is how I'm going to proceed. So this is 254, and then this dimension is also 254. 254. Okay, exit. Okay, now you know what? Let me hide this surface for you, the orange one for you. Okay, there we are. This is the sketch that I created, and did I call it top face? Yeah, good. So all right, so uh, put a face through it, put a surface through it, fill FIL right there. Okay, so this is going to be the top one. Properties. This is going to be top, and I'm going to join this. All the steps that I have followed before, I'm going to join this. Okay, and make sure this, rename this thing first of all, properties top. Make sure that the arrow, the join arrow is pointing down. All right. And extract the boundary of this. The reason I want to extract the boundary of this is that I want to use that as the contour of the ply that is going to be. That's one option. Or I can use the sketch as the contour. That can also be done. Okay, so let me actually rename this thing to be the top sketch so that you remember. You can use that for using it to define the layer, okay, the contour of the ply. Now, while we are at it, let's also create an axis system. This is going to be used as our rosette. So it's the default, which is put at the global origin, which is there, and uncheck this so that it's not current. Okay, good. So again, I'm not assigning any materials here because my plan is to, actually here we have to create our ply. So while we're here, while we're in this part, we go to composite design and material. First, you composite parameters, create your composite parameter, add material. Remember, I created that material library desktop. It was right here. This is the one that I created. And all I need is the skin. Okay, I don't need the core. I'm not going to use the core for my laminate. So we say okay. And this is fine. Rosette is add a rosette, and there is the rosette that I'm going to be using. Okay. So here is your material. This is your material parameters. Then I'm going to create a ply group. There's a ply group. This is the surface. Okay, and the draping direction, I'm going to make it up. You see that right now it's pointing down. I'm going to make it up, and we say okay. And so this is the group that was created. Just so that I can keep track of things, I'm going to rename this thing to be the top price group. Top. Okay. All right. Let's create our lamina. There is the ply belonging to this group, and for the contour, I use that sketch. Remember, I said that I can use this. And material is the skin. Okay, direction is 0. We're assuming that these are all in the 0 direction. All right, so notice that here is my ply. Here's the ply. I repeat the same thing for the bottom ply. So we are done with this. Let me go ahead. Let me double click on product, save everything. All right. Now notice that my part is still here. If you look at it, the core, I hid it, but it's still there. And right above that, which means below this guy, also sits. Let me hide this. That orange surface that I'm going to mesh to create the core mesh. Okay, so let me hide this thing again. All right, and there is my top surface. Now we do exactly the same thing. So we're going to insert new part in that product. Say no, rename it to be the bottom face. So right click properties, but bottom BOT face, and same thing for the part name. That was the instance name, bottom face. Once again, I want to remind you that I'm creating the parts where they should be instead of creating them differently or in different places and then assemble it. This is my favorite way of doing it for simple problems. Okay. Now we want to make that bottom face. You double click on this line. It takes you to, well, it takes you to the what is this? It takes you to the composite design, but that's because the last time I was there, I was in that particular workbench. So part design. Ooh, not part design. Surface generative shape design, because I want to create a surface. The first thing that I do is I create a plane underneath. So just like I did 9mm above, now we're going to do 9mm below. So where's the plane? Right there, from the XY plane in the other direction, and the offset is 9.525. Okay, notice it's created. It's right there. This is the original XY plane. This is the plane that I created for the upper skin, and this is the one that I just created. So on that plane, on that bottom plane, I'm going to sketch a rectangle like that, or a square like this. There are faster ways of doing these things, I understand. This is 254. 254. And then this one is also 254. Oh, not this one. So delete. Okay. Oh, undo. Okay. I want to delete this dimension. You select it, you delete it. Okay, good. So this is the one that I want to be 254. 254. Exit. Fillet, F-I-L-L. Steps are identical. And let me see now. First of all, I'm going to call this thing bottom, right? Properties, bottom. Just like I did top over there. This fill, I'm going to say bottom. I'm going to join it. Right click properties, bottom. Okay, so everything looks like that. We have created our parts. So while we are at it, we can use this other rosette here. That's okay. We can use this one as our rosette for the composite design. It's okay. So I'm not going to create another access system here. Now we're going to go into composite design parameters. Add the material, the library that I had, goes right here. Once again, just the skin. Okay. And for the rosette, add a rosette. I can use the same old one. Okay. All right. So now we're going to do our plies. Ply group first. Here it is. The surface is the bottom, this bottom one. See that? The bottom one. And yep. And the direction downward. The stacking direction downward. All right. So it's right there. Maybe I should rename this thing properties, just like I did the top one. I think I called the top one, so that, can't remember. Uh, what was it? Top plies group or the bottom plies group? Properties. I'll call it bottom plies group. Okay, and then I'm going to create the lamina, the single lamina that's there. So ply single lamina or ply that's there. You select this. For the boundary, use the sketch, bottom sketch right there, and material and direction are correct. Okay, so save everything. To save everything, my suggestion is that go to top level assembly to make your job easier, and then click on the save. It'll do everything for you. All right, good. Now, As far as the model is concerned, we are done. Your core is also there. If you say show it to me, it'll show it to you right there. But let's do the meshing first. So I'm going to uncheck this or hide the core. Okay. Actually, I'm going to show the core, hide the top and the bottom surface, hide and hide. Okay, good. Remember, I extracted the top face of this block because I want to mesh it with shell elements and then sweep it through the core to get 10 layers of my solid elements. And then I can't delete this because I'm using it for sweeping operation, but I can deactivate it. I don't need to use this, okay? So, well, first of all, let's go ahead to the advanced meshing tool. You're there, okay? Okay. So first thing, I want to make a shell mesh here. So let's click on this. This is a surface. 25.4, give me 10 this way, 10 that way, and mesh it there. And while I'm here, I'm going to exit this first, okay? And then you look at the solid elements right there, and then you sweep. Sweep. Remember, it is asking you, look at the bottom left corner of the screen. It says select the volume to mesh right there. Select the volume to mesh. You can see that. So I'm going to select this block that I created. And now I can select the top face. See that? It really doesn't matter which one is bottom, which one is the top. So this is the one that I'm going to sweep. We call it the top, okay? And we want to sweep all the way to the end. And we want how many layers? 10 layers. Uniform 10 layers, okay? Now something, inadvertently I selected two faces. I'm sorry, cancel that. It's better to cancel it, okay? So sweep, the volume we selected, right there, there's the volume. Top face is this guy. For the bottom face, you go and select the bottom, okay? And mesh 10 layers and we say apply. So it's going to give us 10 layer, you can see that, 10 layers through the thickness. Now, we say all right, and notice that here, where is this? Under nodes, it created, this is the one that we no longer need. I cannot delete this. I should not delete it. Let me see if I can delete it. If I delete it, well, I guess, okay, I guess you can delete it. I was going to say the other option is to deactivate it. Deactivate means it's not going to participate in my mesh. The only reason that you may want to keep it here is that later on, if you want to change the sizes and things like that, then if you deleted it, you can't do it. So let me deactivate it. Okay, deactivate. We don't need this. Just remember, we don't need this. Okay. In fact, let's give it a name. This is call it properties. I'll call it dummy shell mesh for sweeping. Dummy shell mesh for sweeping. Okay, so we know where it is, what it is actually. Okay, so let me deactivate, let me uh, deactivate this, not deactivate, hide it, you see. Okay, good. Actually, we don't need this part either, so we can do it either from here, let's go here, let's go there, and hide that part. But we do need these other guys that we are hiding. We need this. This is the top face. So again, we click on it right there, surface mesher. You click on it, you select that surface, same size, quad only. You say OK, and we mesh it. There we are. And exit. Okay, so let's call this thing the top face. Properties, top shell, not the dummy one. And repeat the same thing for the bottom one. So let's hide this guy, bring the other fellow into the show mode, bottom surface. Okay, so we repeat uh, surface measure, select that, same size, okay, mesh it, okay, and exit. Okay, so let's call this thing the bottom shell, properties, bottom, UT shell. Okay, we are in on the roll. Now, notice that these things do not have any properties associated with them. Okay, so first of all, let me go to the advanced meshing tools, not the advanced meshing tool, generative structure analysis, because this is where we apply loads and properties and things, etc. I'm going to hide this rosette for you. Okay. What is showing here is let's do the top and the bottom faces. Hide, show. Okay, good. Let me also hide this rosette. All right. So we want to define the properties of these things. So the way to do it, these are composite properties. So we go to the where is the toolbar for properties? Right there. Composite properties over here. Okay. The top surface. There's a top surface. Okay. Applies. Click on the applies. Go and select the applies for the top surface. It's right here. Right there. Top group. And remember, this is a one-sided stacking. You're stacking in the outward, upward direction. You say, okay. Now, we can change the name of this so that you know what you have done. I can change this thing to be the top. Properties top shell. And repeat this thing for the bottom shell. Okay. So once again, import composite properties. This is going to be the bottom surface. For the plies group, I have to go and get the bottom face plies group from the tree. This is the one. We say okay. Once again, it's not symmetrical. Stack them in the draping direction that we specified. Good. So this one I'm going to call bottom. Properties. Now, in all likelihood, when you do this thing, you will ignore all these renaming and things like that, but it's a good idea to do this thing systematically. Then I want to define the properties of the core. Okay, properties of the core. Okay, so first of all, let me hide these two. Top face, I'm going to hide it. Bottom face, I'm going to hide it, and bring the core into the picture. There we are. Now, of course, this particular face I don't need it. I can hide it, but that really doesn't do anything. Just to remind you that we are working with this. Okay, now this requires a 3D property. See the mesh? The mesh is right here. Let me see. Yeah, the mesh is let's look at our mesh properties, mesh visualization right there. Okay, and the mesh is here, but it doesn't have any properties associated with it right here. Okay, so what we're going to do is the following. We're going to say, okay, define a material property down here. See that? User material. I'm going to go to my library. Can't find it here because I created that honeycomb material in my library. This was the one, and the core is what I want. Okay, the core. This is already used for the composite. This is the core that I want, and I say okay. So I already defined a user property. Let me rename this thing to say the core. I'll put the core in the front so that you will remember what it was. All right. Now we're going to do 3D property right there, 3D property, because there is none here. 3D property. It says, what is the support? Well, the support is that sweeping element. Don't try to select a geometry. Select this 3D mesh. Okay. And for the material, it's a user material. Click on this and go and select that user material that I defined here. Okay. Now, please watch the next video 2034 to have a better idea of what this thing means. I already talked about it. I already talked about in the previous video 32, but I said that the next video 34 is going to be talking more about the sky. But for now, we don't have to do anything. Okay? You say okay. If this sandwich plate was slanted at some orientation, then I would have to worry about that direction thingy. Okay, so very good. Okay, I want to show you something now. Let's zoom in. First of all, I'm going to change the color of the top and the bottom shell elements. So put the cursor there, right click, properties, and I'm going to change the color of that to yellow. And this one, the bottom one, again, properties. I'm going to change the color of that to, how about making it maybe magenta. Okay, so notice that there's a bottom shell, this is a top shell. Now we're going to zoom in. I want to show you something. If you put in the cursor and trying to get one of those shell elements, which is the one, okay, right there. This is shell number 1001. And if you read the numbers, for example, the one in the corner, right in front of you, the closest one in the corner, it says node 4954. Now, if you go below it, slightly move this thing so that it picks up the solid, this node 4954 becomes node 3. That's because you have two independent meshes. The shell elements on the top, solid element below it, these do not have the same nodes. And the same thing is true for down here. If you go, let me rotate this thing a little bit. Look at this element that's closest to you. If you select the shell, it says 5000, node 5306. But if you select the solid, it's a different node number, 345. Because these are not the same nodes, but they have to move together, because if these are perfectly glued together, these are kind of the same things. What I have to do is I have to create a connection, analysis connection between three parts. Whenever you're doing assemblies, you need to create connections, analysis connections. So first thing I'm going to do, I'm going to deactivate the mesh. Okay. I'm going to bring in the surfaces, these that we're hiding. This is the top one. Where's the bottom one? Bottom one is here. Okay, now to create connections, we're going to create analysis connection, general analysis connection, which is right here. You know, stuff like this has been done many times in the FEA playlist, because we teach these things to our third-year students. So we do assemblies and things like that. So if you want, you should go back and look at some of those videos if you want. But there's enough here that you can do the problem. So you click on it. It says select the two components that are going to be interacting with each other. Okay. So for example, my first component, I'm going to select the top joint right there. You can see that. I don't know what I picked here. Let's make sure this top joint that I picked. Let me cancel that. Try it again. I'm sure it's okay if you pick it from here, but I want to go and select it from the tree. Okay. This thing, right? Oh, this was the core. Oh, that's why I had to be careful. I had to be careful here. This is, you see that? I want to select the surface that you see here actually belongs to the core. It's not one of the two surfaces that are created. So it's better to do it from the tree. So this is the top face, and the second component is going to be the top of the block. Okay, so I'm going to right click, hide this. Actually, let me see for a second. for the second component. Okay, so we go there. I want to select the top of the block. I was hoping to be able to select the actually yeah, to be able to select the gray face, but that's okay. We can't do it, but this is fine, because when you hide this, you see the block goes with it. So it's all right. This is going to be fine for the okay. So look, for the first component, I selected the top join, and for the second component, I'm going to select this. It looks like I have no choice but to select uh, that face. I was hoping to be able to select the, the actual block with it, but it doesn't look like it. But that's okay. Let's see if it does the job. Okay, face. So this guy is the yellow piece from the block, and the first one was the surface. Good. All right. Now here's the first connection that is created. There it is. So I'm going to rename this thing. Right click properties, and I'm going to say uh, uh, top, top skin and top face of the block. Okay. I was hoping to literally be able to select the gray thingy, but it doesn't look like it. Okay, good. Another one, another connection, analysis connection. For the first component, I'm going to select the bottom join. So where's the join here? This is the bottom. There is the bottom join. And for the second component, now I can select the bottom of this block, because this, what you see here, is actually bottom face. So I'm going to hide it. Okay, so uh, me let me let me do exactly the same, because it won't let me select the bottom of this gray block. So we'll see how it works. Okay, so this one is going to be properties. So let's call this thing bottom skin, and the bottom face of the block, bottom face of block. Okay. Now these two connections that are created, they're glued together. In other words, the skin is glued, or through an adhesive glued to the honeycomb, and the same thing with the bottom. So that is what we call fasten. If you go to face-to-face connection properties right there, we created the connection. But now face-to-face connection property, you see something, the third one on the left says fasten component. You click on it, okay, and let me cancel that. Try it again. You click on it, it says which connection? Well, the top one right there. It puts a fastener sign there. This has nothing to do with nuts and bolts and things like that. All that means is that they're glued together, they move together. And another one for the bottom, that's putting at the bottom, and we say okay. All right. So a couple of things. First of all, some of the stuff I don't want, because I still have to apply my restraint. So let's go ahead and do the ones that we can. First of all, right here, clamp, this face, that face, that face, and that face. Okay. Now what I want to do, I want to put a clamp on the edges, of those top skin and the bottom skin. However, the problem is that when I say clamp, I try to pick it, it's tough, because there's a bunch of things that's blocking our view. So let's go ahead and either hide it one by one from the screen or from the tree. So let's try one more time. We go try to select this, it won't let us do it. So let's hide it. Right click, hide. Something disappeared. Again, won't let us take it. right click, hide, right click, hide. Now we can pick the edges. The reason was that something was blocking our view. The connection, these connections that we created was blocking it. The sketch, the ply contour was blocking it. And the sketch that we created to make this surface was blocking it. But now we can pick it. So this and that and that and that. And we repeat the same thing for the bottom one. See, we want to clamp the bottom edges of this of the surface, but it won't let us do it. So see, it won't let us do it. So we're going to hide it. Right click, right click, right click. This last one is probably the sketch, and now we can select the here uh, this guy and that guy and that guy and this last one. Okay, and finally the pressure. We're going to put pressure on this face. So where is the pressure? Right there on that face. This is the correct value from your pressure down here. Say OK. Let's save everything. So File, Save Management, Analysis, Save As, or we call it Assembly. Say OK, and we say OK, and run it, but make sure you pray. All right, now look at the deflection, 1.78. Very close to what is reported in the reference that I'm trying to compare it with, right there, very close. Okay. Now the rest of it is fairly straightforward. So, for example, if you want a deflection in a different rendering, right there, a couple of things, and that is notice that this kind of doesn't look very good. So what I can do is I can go to deflection here, double click on it, and say, okay, just show me the swept, for example, the top shell. Just show me the stuff for the top shell. This is a deflection of the top shell. Okay, if you want to see the bottom shell, you select the, this was the bottom shell. If you want to select the top shell, you select this, both on the bottom and the top. If you want to see the deflection of the core, you just go ahead and select the sweep. Now, remember that this doesn't mean much because these are all moving together, okay, because we made them fasten. So cancel that. Let's go ahead and look at the, if you see some weird stuff here, by the way, that's because these are the internal elements, connections that were created. If you don't want to see these, these kind of internal elements, see these lines, then that's easy. You just double click on this and select, just on the selection, just select the sweep, for example, sweep and the shell and top shell and the bottom shell. Then those internal elements are not displayed for you. Now, if those internal elements are stuff like this, okay, which are totally useless as far as the user is concerned, so don't look at those. Now, let's look at the von Mises stress. Von Mises stress is right here. First of all, this is all kind of smooth image. So double click on the legend, select these dots, 3 dots, say don't show it to me smooth, unsmooth it. There we are. Now, what are we watching? What are we looking at? So double click on the line that says von Mises stress. And if you want to see the, the, the top shell, and you're not going to be able to do that, Remember, because these are composite layers, you won't do it like this. Or the bottom shell, you won't see it. But if you say show me, but if you show me the sweep 3D, you get this. So what you're actually looking at is the stress distribution in the honeycomb core, okay? And very low stresses, you can see that. Now, if you want to see the stress distribution in the top shell and the bottom shell, or top ply and the bottom ply, you can't do it like this. Say okay, deactivate this. The usual way, you put the cursor here on the static case solution, right click, generate image, and select the stress. Under full stress or full stress contour, nodal values. Okay, so what are we looking at here? So double click on this, on the selection, on the visualization. If you want to see von Mises, so what you're seeing here is, let's see. If you want to see the top shell, just double click on it. This is the stress, this von Mises stress distribution in the top shell. And if you want to see the bottom shell, this was the top and this was the bottom. But if you try to plot the von Mises stress in the swept element, it won't give you anything. Okay, so let me take these things up. Let me take the sweep 3D element, come down. Well, actually, it does give it to you. I'm sorry. Now, this is the same contour that we looked at before, but you can visualize it this way too. Okay, but when last time, if you do it from here, you won't be able to see the top and the bottom shell stress distribution. But here you will. Okay, so if you want to see the top shell, there we are. If you want to see the bottom shell, actually the other way around. This is the bottom shell. Why do you have two of the? Oh, yeah, this is the top shell. Yeah, this is the top shell, and there's the bottom shell. Okay. Now, if you want to see this, the 3D element, it shows it. There we are. That's what I was thinking. Yeah, I'm sorry. So let me take back what I said. So if you go this route, okay, if you go this route, you can see the bottom shell. You can see the top shell, but you cannot see the one in the honeycomb right there. See, they're all zero. This is exactly what happened to us when we did all shells and all shells in, for example, video 32. Yeah, I'm really sorry about this. So let me try. This is important, so might as well know what we're doing. Right, deactivate this thing. First of all, the standard von Mises stress distribution from here, if you activate it, it shows you the core, okay? It will not let you select the plies. That's as simple as that, okay? Because if you double clicked on it and you say, okay, I don't want the swept 3D, I want the top shell, it won't give you nothing. Cancel. If you want to see the stress distribution in the plies, so deactivate the von Mises from there, activate this one, and double click on it. Make sure you have selected von Mises, for example. And on the selections, let's say that we want to look at the bottom shell. There's the bottom shell. Let's say you want to look at the top shell. There's the top shell, okay? And let's put these things back where they belong. If we say, show me the swept 3D, try it again. Okay, let's try it one more time. Okay, on the selection, there, okay. It looks like this is kind of weird because it looks like if you do, let's try it again, double click. If you say, okay, show me the top shell, shows it to you. And then show me the bottom shell, it gives it to you. if you say, show me the swept 3D, it gives it to you. But here, look, watch what happens. If I say first, show me the swept 3D, it gives you 0. So depending on how you pick it, you may get 0, or this is very weird, but that's the way it is. Okay, so I solved this problem 3 different ways. Only shells for the 3 components: skin, core, skin. Then I did as a single part. The skins were shown with shell, were done with shell, and the core was done with solids, brick elements, and as a single part. And right now, I repeated that where the parts are within an assembly. It's not a single part, it's 3 parts. And I'm really sorry about this last stage where things kind of, it was wacky depending on how you picked it. It should give you 0 stress in the core, but it was not giving it to me when I was going through this branch, okay, unless you pick those in a very special order. But the point is that the top skin and the bottom skin carry most of the stress. You can see that, but the honeycomb carries very little stress. You can see this. Right click, activate, only 8 megapascal, okay. Whereas for the top skin and the bottom skin, one Mises was around I don't know, 100 and something. All right, good luck.